Okay, so we have four students for interview. Okay, and I'm starting alphabetically. Okay, so Dhananjay, you are first. You can make your camera on. So we are starting with you. Okay, Dhananjay. Yes, Dhananjay.
Good
So,
afternoon, sir.
so can you give you a brief introduction of yours?
Sir, my name is Dhananjay Mishra. I am from Rajasthan. I completed my MSc with University of Rajasthan.
Which university?
University of Rajasthan.
Okay, okay. So what was your specialization?
सर अभी तो प्रिपेयर मतलब न्यूक्लियर फिजिक्स किया है
अच्छा,
और सॉलिड स्टेट, हाँ सॉलिड स्टेट फिजिक्स किया है।
ये तो आपका सब्जेक्ट है। स्पेशलाइजेशन क्या है? स्पेशलाइजेशन कुछ होता है ना सब्जेक्ट एमएससी में, कुछ जो ऐसा टॉपिक होता है जिसमें आपका स्पेशलाइजेशन होता है?
सर वैसे तो मतलब कि हाई एनर्जी फिजिक्स
हाई
था,
एनर्जी।
लेकिन अब एमएससी की हुआ मतलब 1 साल हो गया था,
अच्छा अच्छा
तो अब
अच्छा।
मतलब
ओके 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 ओके। सो लेट अस स्टार्ट। ओके,
ओके
सो shall I start with solid state physics?
ओके सर।
Okay, so what is superconductivity?
सर सुपर कंडक्टिविटी, so superconductivity is a kind of phenomena in which a substance is lowered when substance is lowered at temperature.
Okay,
Then
okay,
it,
okay, okay. I like to stop you. One thing, whenever a question is asked in the interview, okay, so this physics, okay,
yes,
physics is never explained by just in words and talking. Okay, you need to always go to the board, and physics को जो भी है, that will be always come in mathematical expression or in form of graph.
yes, sir.
Okay, that is a way of explaining
Okay,
physics in
sir.
interview. So you draw some graph, okay, and show me what you mean by superconductivity. Are you getting my point?
Okay,
जो भी बताना है
सर
वो
इसमें
लिख
कैमरा
के
मतलब यस सर, यस,
हाँ।
ओके सर।
नहीं, कैमरा तुम लिख के फिर कैमरे पे शो कर दो, ऐसे लिख के फिर कैमरे पे शो कर दो मुझे, बस वो हो जाएगा।
सर ऐसे, सर
हाँ,
ऐसे भी
ड्रॉ।
कर सकते हैं।
हाँ, कैसे भी करो, ड्रॉ करो, बस मुझे दिखा दो बस खाली।
ओके सर।
गुड, वेरी गुड।
सर स्पेसिफिक काइंड ऑफ सब्सटेंस होते हैं जो किसी पर्टिकुलर टेम्परेचर टी के बाद सडनली इनकी रेसिस्टिविटी में ड्रॉप आता
हम्म, सडनली ओके,
है।
फाइन। ओके,
So that phenomenon is not it.
so can you tell me, can you draw M versus H graph for type 1 and type 2 superconductor?
Yes, sir. Sir, for type 1 superconductor, it is a proportional type, and then it goes like that. This is known as the field distance Hc1, and this is known as Hc2.
Okay.
Up to Hc1, the substance is found in type first condition, and after that, between Hc1 and Hc2, it is found in the nature mixed state, in which normal as well as superconducting state are collapsed, and that is known as the second type of superconductor.
Okay. Okay, so this is minus M versus H plot. No, this is for type 2, and you are saying first reason is type 1. Okay, that's fine with me.
Yes.
Okay. Now see, what is the main use of superconductor? If I see in a laboratory, so all the high magnetic fields are produced by superconductors. Okay.
Yes,
Suppose
sir.
I want a laboratory 10 Tesla magnetic field or 20 Tesla magnetic field, that we cannot produce by
Yes, sir.
A simple copper coil or any coil. Okay, that we need a superconductor.
Yes, sir.
So
Yes,
here
sir.
you're saying that applying superconductor, that magnetization goes zero. That means your superconductivity get vanish. Okay, with applying magnetic field, isn't it?
Yes, sir.
So one way we are saying that superconductivity can be destroyed by applying magnetic field, and another other way we are producing high magnetic field using superconductor. Superconductor का main use यही है अभी तक, ठीक है? You are producing high magnetic
Yes, sir.
fields. तो ये कैसे होता है? जैसे मुझे अच्छा ये इसका क्वेश्चन का अगर आंसर आपको ढूंढना है तो व्हाट आर द टिपिकल वैल्यू ऑफ SC1 एंड SC2? डू यू नो सम वैल्यूज ऑफ अबाउट SC1 SC2? SC2 की वैल्यू कितनी होती है, कुछ कुछ पता है?
SC1 की तो बहुत कम होती है
हाँ,
और SC2 की कुछ ज्यादा होती है,
कितनी मतलब कितनी होती है, कोई आइडिया
लाइक
है?
सर लाइक 4 टेस्ला
हम्म, ओके। सो SC2 वैल्यू इज
सर
वेरी
प्रूफ
वेरी।
ऑफ स्ट्रेंथ।
हाँ, तो अगर मुझे हाई मैग्नेटिक फील्ड प्रोड्यूस करना है तो मैं कौन सा सुपरकंडक्टर लूंगा, टाइप 1 और टाइप 2? आई वांट टू प्रोड्यूस
सर
हाई
टाइप
मैग्नेटिक
सेकंड।
टाइप type second. Okay, I use type 2 superconductor. Okay, because the critical magnetic field value is very high,
यस सर।
50 Tesla, 90 Tesla, 90 Tesla, 97
यस सर।
Tesla. So if you want to, so if even if you were to produce 20 Tesla, 10 Tesla, you still are safe because critical magnetic field values are very high. Okay,
यस
so type
यस
1
सर।
superconductor has a very less technological application, where type 2 you can have many applications. Okay, okay.
यस सर।
So can you tell me now about some dielectric materials, or are you interested in dielectrics or magnetic material? In which topic you are comfortable?
सर अभी आवाज क्लियर नहीं है क्या आपकी?
I'm
कैन यू
asking,
रिपीट प्लीज?
shall I ask you about dielectric material or magnetic material? किसमें comfortable हो ज्यादा?
यस सर।
Hmm. So can
सर
you tell
मैग्नेटिक
me
मटेरियल।
magnetic material? So you differentiate different type of magnetic materials using M versus H curve.
यस सर।
Different type of magnetic materials.
यस सर।
Uh,
यस सर।
बताओ कौन कौन से होते हैं डिफरेंट टाइप ऑफ मैग्नेटिक मटेरियल्स?
सर एक तो डायामैग्नेटिक होता है,
हम्म,
जिसके लिए मतलब कि M/H रेशियो मीन्स वैल्यू ऑफ काई
हम्म।
इज टेम्परेचर इंडिपेंडेंट। एक होता है पैरामैग्नेटिक, जिसके
एक्स की
लिए
काई की
काई
वैल्यू
की
कितनी?
वैल्यू
टाइम मैग्नेटिक के लिए काई की वैल्यू कितनी होती है?
सर नेगेटिव बहुत कम होती है, अप्रोक्स 10⁻⁻⁷।
और नेगेटिव होती है? यस, ओके।
यस सर।
हम्म,
एंड फॉर पैरामैग्नेटिक इट इज पॉजिटिव एंड इसकी भी कमी होती है वैल्यू, एंड इट इज टेम्परेचर डिपेंडेंट
हम्म,
which is given by proportional to 1/.
ओके।
And after that ferromagnetic material,
हम्म,
उसके लिए chi which is the ratio of M versus H, इसके लिए
हम्म,
वैल्यू पॉजिटिव होती है एंड वेरी हाई होती
हम्म।
है एज कम्पेयर
प्लॉट
ऑफ पैरामैग्नेटिक।
प्लॉट एम वर्सेस एच कर्व ऑल थ्री मटेरियल्स।
so this is like
तो दिस टॉप वन विच इज डायमैग्नेटिक?
सर
डायमैग्नेटिक
जो एच लाइन के बिलो है।
डायमैग्नेटिक नेगेटिव है ना? नेगेटिव में तुम
यस सर।
पॉजिटिव ड्रॉ कर रहे हो,
नहीं
तो
सर वो
पैरामैग्नेटिक।
नेगेटिव है ना।
नेगेटिव में कहाँ ड्रॉ किया? नेगेटिव नीचे ड्रॉ करना पड़ेगा, y इक्वल टू माइनस एक्स ड्रॉ करना पड़ेगा तुमको।
सर एच लाइन ये वाली
अच्छा, नीचे वाले, वेरी गुड, ओके ओके, दिस इज वेरी एज दिस इज डायमैग्नेटिक, ओके, और पैरामैग्नेटिक ऊपर वाला, ओके,
यस सर।
एंड द टॉप वन इज फेरामैग्नेटिक।
यस सर।
ओके ओके, नाइस, वेरी गुड, ओके। सो अभी व्हाट इज द डिफरेंस बिटवीन हार्ड मैग्नेटिक मटेरियल एंड सॉफ्ट मैग्नेटिक मटेरियल्स?
ओके सर। सर फॉर सॉफ्ट मैग्नेटिक मटेरियल्स highest hysteresis loss is low, while for hard magnetic materials, highest hysteresis loss is high.
यू
And
ड्रॉ द हिस्ट्रेसिस कर्व एंड शो।
yes, this is for art.
Yeah. So this is for hard. Okay. And soft में क्या हो जाएगा?
सॉफ्ट में सर इसका एरिया कम हो जाएगा, ड्रॉ करता हूँ.
Okay. But you draw properly, इसको draw अच्छे से करना. Okay. Otherwise it's okay. Okay. What information you can get from these stress loop?
Okay, sir. Sir, these stress curve shows that when we applied magnetic field in one direction, then our material is got magnetized. But when we drop our magnetic field to zero, then the property of these kind of materials is that they don't get demagnetized completely.
Okay, मैं पूछ रहा हूँ कोर्सिविटी क्या होती है? कोर्सिविटी क्या होती है? कोर्सिविटी.
Yes, sir. So corrosivity is the field in opposite direction at which our magnetic material is completely demagnetized. Here, this is the point.
पूरा ड्रॉ करके होता है कोर्सिविटी पूरा. ओके. और सैचुरेशन मैग्नेटाइजेशन क्या होता है?
Saturation magnetization, sir, here where not when we applied higher magnetic field, but our magnetized it is gets saturated here.
Okay.
At this.
Okay, Dhananjay. Nice.
Okay.
So I'm calling now the student. Okay. Yours
Okay.
completed. Thank you.
Okay.
Next is now Srinivas. Can you switch on your camera?
Yes, sir.
Yes.
Can you hear me, sir?
Yes. Srinivas, please give you a brief introduction.
Okay, thank you.
Srinivas, tell me about yourself.
Yes, sir. My name is.
Yeah. Take your time.
I completed MSc in Andhra University, sir.
Which university? I could not hear. Which university?
Andhra University, sir. Andhra Pradesh.
Andhra Pradesh. Andhra University.
Andhra University. Yes.
So tell me about your specialization.
My specialization is space physics, sir.
Which field?
I think space physics.
Okay, space physics.
Yes.
Okay. Have you done any project during your MSc?
Yes, sir. I have done a small project on an MSc on solar, wind, and interplanetary magnetic field. That is associated with the sun and its properties. Okay. So we're starting.
So since you have some experience on solar cell, okay, can you explain me the working mechanism of solar cell, PN junction solar cell?
No, sir. I am uncomfortable with electronics, so sorry.
Okay. So shall we start with solid? Okay. So can you tell me what is Wigner's lattice cell and Brilliant John?
Yes, sir. That is smallest possible areas in Wigner cell.
Can you draw some Wigner's lattice cell for 1 dimension and 2 dimension for direct lattice?
Yeah. No, sir. No.
Okay. So when somebody asks you this one, then you should be able to at least 2D you should draw. Okay. Okay. So what do you mean by this? What is the difference between axial deflection and neutron deflection?
Because, sir, we know when we have to study the properties of this solids, we have certain condition is there. So whenever the incident radiation, there is a wavelength associated with that radiation, and there is some dimensions of the objects. Whenever we have the radiation wavelength is greater than dimensions of that object, then we cannot study about that.
So basically, my question is,
X-rays are having the very short wavelength.
what is the use of X-ray diffraction? What is the use of X-ray diffraction? Type question is that. What information you
Yes,
get
sir, in
from
order to study them.
in order to study?
So in order to study internal structure and property that
Internal
how
structure of
what is the internal structure? Yes.
internal structure. What do you mean by internal structure? Internal structure means what? You're asking, talking about some nucleus or electron cloud. What internal structure we can?
So only we can study that electron cloud structure, sir, only. Whenever we have to study that nucleus, then we have to use the neutrons and iron.
Okay. Okay. So can you write the density of state expression for 1D atomic chain? Density of state expression for 1D atomic chain.
Density of states, sir.
Yes. Yes.
In K space or I think.
Yeah. Any space. Yes. Just to write in K space. Okay. You just write and show me. Mic on, and the mic should be on. Your camera should be on.
So this is the density of states in 1 dimensions. In K space.
सतीश कैमरा उस पे ले जाओ, श्रीनिवास पे. I cannot see. कैमरा से उस पे ले जाओ ना, श्रीनिवास पे. उसको मेन स्क्रीन पे ले जाओ.
So can it is visible?
Just about 1 minute. Yes. Okay. So this is in 1D. Okay. Now for can you modify this for electron? Free electrons?
Yes, sir. Yes. When we take the electrons in free particles, then
you just show me. Put it there and show me. Yes.
Okay.
No, again.
So this is for free electrons.
This is, you're putting e power. What is the e power? Yes, minus half or plus half? E power is what? G is proportional to e power?
Minus half, sir.
Okay. Good. Okay. So, Shinu, my last question is yes, is good. Okay, can you tell me about what is dielectric polarization?
Yes, sir. When so we already know dielectric. Whenever dielectric is affected by the external field, then there is some charge distribution is there in that. Hello.
Okay.
So there is charge distribution. Then there is a separation between the. It is very small.
Okay, so separation of charges. What term we use for that one? So if I want to say what is polarization, can you define mathematically?
Dipole
Moment.
Yes, it's a dipole moment.
Okay.
There is charge separation. Dipole moment is there. So whenever you study the materials, we can take a particular volume. So dipole moment for particular volume, then we can get.
Yes. So suppose I have a material, okay, I want to measure its dielectric constant at different frequencies. Yes. Okay. So what will the
Yes.
effect of frequency of on dielectric constant? So the one thing is I
Effect
should
of
measure.
frequencies.
So the one thing is I should measure static dielectric constant. Okay, applying
Yes.
constant voltage source. And other way is I apply AC source. Okay, so
Yes.
what will the difference? Whether the dielectric constant will vary with frequency or it will remain constant.
Yes, sir. That will be definitely vary, sir. From the study of the electromagnetics, we can study that variation of the frequencies.
So whether it will increase or decrease with frequency.
So frequency is directly proportional to the intensity, sir. Yes, I think that will be dielectric constant. I think I don't remember that relation, sir, but that will be affected by that dielectric constant of the material, sir.
Okay, Shinu. Thank you, Shinu. Okay,
Okay, welcome.
so I'll start now with, I'll call new student. Okay, the next student is Pushparaj. Okay, Pushparaj. Kunal, are you there? Na?
Yes, sir.
Ah.
Am I audible, sir?
Yes, you are.
Yes, sir. Yes, sir.
Kunal, please.
Okay. Hi, Pushraj.
Yes,
So, yeah, can you please something about your some project or yeah,
Good
please go
afternoon.
ahead.
Good afternoon,
Yeah.
sir.
Good afternoon.
Sir, this is Pushpraj. I completed my MSc from Central University of South Bihar, Gaya. And during the MSc, I completed my project on XPS, X-ray photoemission spectroscopy,
Okay.
the characterization of the vanadium dioxide material.
Okay.
Sir, also I'm from Bihar, and that's why I opt that university, Central University of South Bihar. And during the MSc, I completed and I achieved many more things. And also, in project hour, my work is also acknowledged for the journal, and this was my good achievement. And during the less than 6 months, I complete this. Thank you, sir.
Okay. Okay. So, as you said, your work was on something regarding related with the spectroscopy. So, have you studied about laser action?
Sure.
Okay. So, can you please tell me what are the necessary conditions to achieve the laser action?
Necessary condition of?
To achieve the laser action?
First of all, laser. What is the laser? I'm just a brief introduction. Laser is the light amplification of the stupinated emission, am I right? Of the radiation. Sir, it is the laser. It means that the laser means it is working on the Einstein's theory, and its main three components are working there. That like as the component of the medium, and first one thing, second one thing is the composition, pumping of the sources, right? And third and last one is the optical resonant. These main three components are required for the laser, and a good laser, if you are developed in this situation and this criteria, if you feel.
Okay, so you told me everything, but you didn't tell me what I asked. I just asked what are the necessary condition to achieve the laser action.
Actually, inverse population inversion.
Yeah, exactly. Population inversion.
It
That's
is,
what I
yes. The pumping source, it is the population inversion.
So, I didn't ask about the resonant or something. I just asked you a simple question. What are the necessary conditions for the laser cell? Okay, so can you please tell that if we take a 2-level system, okay, or 3-level system or 4-level system. So according to you, among all these three, which system will be good for the achieving the laser action, means achieving the population inversion? Please tell.
4-level system.
Why?
4-level system, example, helium neon. Here, the population inversion, if you see the pumping the electrons, pumping the particles, and it will go the upper level and this will be drop. And the meta stable state, as first and second, this state here, the particle or electrons, they will be the fall down, and so we get a maximum of the monochromatic lighted. In monochromatic lighted, the photons will be outed after stimulation.
Okay, so according to you, laser action or population inversion will not be possible, means even you can say any single 1% in the 3-level system, according to you? Or is it possible, or there is something else? Can you please tell me the comparative study between 3-level and 4-level?
Their population inversion is the main.
Well, first of all, tell me whether it will be possible to get a population inversion in 3-level system or not. It is possible or not? Just a simple question.
Yes, population inversion is possible.
And in 2-level system?
No, there is no possible.
Okay, now go ahead.
That's why we are not achieving the leisure.
Okay. Okay, go ahead. Yeah.
Yes, sir.
Go
I'm not getting.
comparative study, what I asked, the comparative study between the 3-level and 4-level system. Why the sustainability not happen in the 3-level system? You said the population inversion is possible, right? Yeah, it is
Yes,
true,
sir.
it is possible. So why we need 4-level system if it is possible in 3-level system?
It is not in 4-level system. Second, sir. Sorry, I don't know. It's not audible for me like clearly. So.
Okay,
Sir,
no problem. Okay. You told me the right answer about the 4-level system. Means you know about the laser action, so don't worry. Okay. Have you studied about the ensemble?
in general.
Ensembles in the statistics.
Ensembles. Yes, sir. I have.
So can you tell about the canonical ensemble something?
Yes, sir. Canonical ensembles NVE. There is a constant where N means number of the particles, P for the volume, and E for the energy. It is a constant, and all the particles, other components is variables.
Excuse me, wait. Please again repeat what you said. I think there is some mistake. Please repeat.
Canonical ensemble, in the canonical ensemble, N means number of particle, V is the volume, and E is energy. Am I right?
Okay.
These all are fixed.
So according to you, there is nothing about the temperature in this.
It is a variable.
Temperature is variable in
Yes,
canonical.
NVE, mu Vt, and TVE.
Please again think again once.
Pushpa, just to write
in
all
the canonical ensemble, NV is constant.
Pushpa, just to write all the three assembles on paper and show us.
Yeah.
Okay. Show us
please.
which variable is constant in which assemble. Okay. All you three you write on the paper.
You are confused at some point. Please write.
Oh, sorry.
Yeah. Please write.
तो ये तो कैमरा उल्टा करना पड़ेगा.
We are able to see. So microcanonical you are writing TVE and Grant
Yes,
you are writing UVT and NVE. Okay, just Kunal check it. I don't think it is correct.
It's incorrect, Pushpraj. It's incorrect.
Okay.
Please see. Where is the mistake? Please see again.
Okay. So just you revise again.
Okay.
I will check, sir. Canonical, I will check.
So
you are saying the variable temperature is variable, right? You are saying temperature is variable in canonical system. So how can you write partition function if temperature is variable? The main component of canonical ensemble is writing a partition function for any system. So if temperature is variable, you write Gi minus Ei. So beta is 1 over kT. So if temperature is variable, how can you write the partition function? Its
Sorry, it
temperature,
will be NBT.
its temperature, volume, and number of particle, which is constant in canonical examples. Okay.
I'm confused. I'm confused many more times to E or T. Sorry, getting. Sorry, I will check, sir.
Okay, sure. Can you just a last question? What are just in a canonical example, we write the partition function, right? So can you please tell the physical significance of partition function? What does it represent? Partition function.
Partition function is the mathematical tools. There we calculate the particles. We read the particles and particles. Read the particles. That is the conditions, and then we calculate the pressure conditions, pressures, entropy, and so on, energy.
No. That's the application you are telling about. I'm just asking, what does it physically represent? What does it mean? Writing a partition function, what does it mean? What is partition function? I'm not asking about the energy or thermodynamic property you are getting from that. I'm just asking, what is a partition function? What does it represent physically?
Partition Z is equal to G to the power minus beta I.
Yeah, I'm asking about the mathematical expression, Pushraj. I'm again asking you.
Okay.
Yes, sir. You are asking.
Before I leave, I just want to tell the answer of this. Basically, partition function represents number of microstates are accessible to your system in a given example. Okay, it basically tells the amount of volume occupied by the system in phase space. Okay. Okay.
Yes,
Pushpraj, you have to study statistical mechanics a lot. Okay. You have to revise properly. Okay. So now I'm asking for the question from EMT. Okay, can you write the Maxwell equations?
Yes, sir.
Write the Maxwell equation.
Maxwell equation for the general system, sir.
Right.
Diverge, sir.
Yeah. You write Maxwell equation in vacuum. You write Maxwell equation in vacuum. Okay.
Okay.
All the vacuum.
For the vacuum.
Yes.
Divergent of E is equal to 0. Divergent of B is equal to 0. Curl of B, sorry.
E is equal to right.
Okay, sir. Okay, sir. Sir.
Just be in one place. Okay. So del cross E last equation. What you written? Mu 0 Delhi. What is that?
Mu naught epsilon naught d by dt.
What is that?
Means?
So mu 0 Delhi by del t. What is that?
That is the change of the electric field with respect to time.
So what is that called? So I am asking another way. What is the displacement current?
Displacement current divergent of J. Displacement J. From the equation of continuity, their divergent of hold on, sorry. Divergent of J is equal to minus d rho by dt. For the rho is equal to 0, divergent of J. G is equal.
I'm not asking about conservation.
We may write sir mu and J because J is constant there.
No, what is actually definition of? I'm just asking what is the physical significance of displacement current? What is displacement current?
Displacement current ID. So displacement current means when the electrons is moving in a path in any path, then the initial and the final state, their electrons move one to another point I to F. That is the current displacement current.
Okay. So can you write the expression for electric field? Okay. Due to a current carrying wire, a long wire is carrying current. Just write the electric field and magnetic field values. Expression for electric field and magnetic field for a current carrying wire, a long infinite current carrying wire.
I don't know.
So this is a current. Okay, this is a conductor. Okay, which is carrying current. Okay, infinite conductor. Due to this wire, what is the value of magnetic field and electric field at distance r? Can you write the expressions?
Electric field is the inversely proportional to the R square.
You just write the expression for B and
The
E.
magnetic field E is equal to 1.4 pi epsilon naught R square.
Right, I cannot hear. I can understand. Just you write on paper. What is B? Write on paper. What is B?
B for the
Magnetic field.
For the line, sir?
For the current carrying conductor. Long conductor. Long current carrying conductor. You show the BE with direction. Okay, leave it. Can you tell me what is Ponting vector?
Ponting S is equal. What is it? Is the energy per unit area per unit time.
Okay.
Yes, sir.
Okay.
Half 1 upon mu naught E cross B.
Okay. So how electromagnetic radiation interact with the metal? Okay. So if I'm shining electromagnetic field on metal, what will happen? If it's a good conductor. Okay.
Yes, sir.
So if it's a good conductor, I'm shining electromagnetic wave. So what will happen? It will absorb, it will reflect. What will happen? A good conductor.
Okay, good conductor reflection. I was asking about the good conductor reflection. Am I right, sir?
It is reflection.
Or the good conductor. Yes, sir. Good conductor is the reflection.
Reflection.
100% reflection.
Okay. Can you write the
Yes,
formula for skin depth? Skin depth.
Yes, sir. Yes, sir. D is equal to 1 upon root under pi. Sir, D is equal to root under 1 upon pi sigma mu f. Can I write pi sigma mu f? Skin depth. D, sir. There. D is equal to root under pi sigma mu f.
Sigma
1 upon root.
Okay.
1 upon 1 pi sigma mu and f.
Is there any frequency there? Frequency is there?
Yes, sir. Sigma. Yes. F is the frequency, sir. 1 upon f.
Okay. 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 So thank you. Okay. We'll call now next student or next student Sonal. Okay.
Thank you, sir.
Thank you. Thank you very much. Sonal.
Good morning, sir. Good afternoon, sir.
Good afternoon. Okay. Sonal, can you give your brief introduction?
Yes, sir. Sir, I did my bachelor's in physics from Miranda House, University of Delhi, and post that I've done my master's from University of Delhi, Department of Physics and Astrophysics.
So your specialization is the astrophysics.
No, sir. It's theoretical high energy physics.
Okay. Okay. So, Sonal, can you show me the wave function of harmonic oscillator? Ground state wave function of harmonic oscillator. Can you draw?
Yes, sir. It's something like this.
Ground state.
Like a Gaussian.
Okay. So now, can you write the density of states? Okay, for a one-dimensional harmonic oscillator, quantum harmonic oscillator, density of states.
So I need to think about it.
Yeah. Just you show me the methodology of how, or if you one-dimensional is you are not able to find the idea. So can you tell me or two-dimensional harmonic oscillator, quantum harmonic oscillator?
Sir, for 1D, as far as I remember, it was square root of 1 by E dependence. So E depends on n plus half h cross omega. So it has to be 1 by square root n for 1D.
How do you calculate? Just write the expression for 1D one-dimensional harmonic oscillator. Just show me the expression, energy expression.
Sir, I don't remember the coefficient. I remember the dependence on E.
And you just give me the energy expression na, for harmonic oscillator.
Okay. So this is the expression of energy.
So what is N here?
N is the level, nth level,
Level. Okay.
quantum number.
So if I ask you density state, so what will you do now? dn by d, that's it.
Yeah.
Okay, because this is level, single levels na only here. Single levels, just do dn by d. Okay. Now, if I ask you to write the expression for this two-dimensional harmonic oscillator, okay, so give me the expression for energy. Two-dimensional harmonic oscillator. Okay. Okay, very good. Can you draw this? Can you draw this curve or on nx and y? You're taking the axis nx and y.
Yes, sir.
Draw this curve. What this figure is there? You have nx and y.
It would be three-dimensional.
It is two-dimensional. How will it be three-dimensional? You have nx and y.
But I have to plot E also. So that would be the
E is
third
constant. E is constant. You take nx.
Okay.
Your variable is nx and y. X plus y
sir.
only. So
Okay. So that would be linear curve.
linear line, equation on line.
Yes, sir.
Draw that line.
Okay, sir. It would be something like this.
Okay. So you have to show me the intercept also. What are the intercept?
So
Okay.
this is the intercept, and its value would be E by h cross omega minus 1. And this is the intercept on y-axis, and on the x-axis,
Also.
when n.
Okay. So this.
Sorry, I said the reverse.
So can you write the can you write the now number of microstates? You tell me microstate will be proportional to what? You just h cross omega. You can neglect that one. Tell me what is the microstate will be proportional to?
I don't remember.
Can you remember what is microstate? How can you calculate microstate? If you know the area, can you find out the microstates?
So if we know the area and the phase space in P versus X, then we can. But here it's Ny versus Nx.
So basically, whenever we have a three-dimensional or two-dimensional structure, you calculate the area or volume that is proportional to their microstates, isn't it? If I want number of microstates, that should be proportional to the area of this curve.
So, but that
area is what? Triangle.
Area is, so is it not in phase space?
What nx and
P
y?
versus X.
That is nx space, na? Space can be anything. K space, nx and y are number space. So I'm asking this number space, nx and y. Okay, where each state is distant by nx equal to 1 and nx equal to y. Like you have kx equal to 2 pi l, ky equal to 2 pi l y. See here you have a number like in particle box nx and y. So nx and y shows one state.
Yes.
Okay, nx and y shows one state. So you find out the area. What is the area?
So area would be half nx and y.
No. See, you have intercepts, na?
Oh, yes, sorry, yes.
So what is the base? You know height. You know base.
Yes.
You know height.
So it would be E minus 1 whole square by 2.
So basically, it is proportional to E square.
Yes.
Okay. Basically, this is proportional to E square. N is proportional to E square. Okay. Now, if you do density state, that will be proportional to E.
dn by dt.
Dn by d. Okay.
Yes.
So this is for two-dimensional harmonic oscillator. Okay.
Yes, sir. So
If I give
proportional to E.
you now, if I give you three-dimensional harmonic oscillator, what do you expect?
So it should be E cube for volume, proportional to E cube, and so E square for density of states.
Okay. So now my question is from semiconductor. Okay, can you share me help the difference between a direct and indirect band gap semiconductor?
Sorry, sir.
Direct and indirect band gap semiconductor.
I don't know.
Okay. Can you draw the resistivity versus temperature plot for extrinsic semiconductor?
No, sir.
No. Okay. Kunal?
Yeah, hi Sonal.
Hello, sir.
Okay, so there's many questions from solid state. So I will go to some mathematical physics. So can you please tell me why we need to study the Fourier transform? What is the physical significance?
So it's basically we are going from one space to another space. Sometimes, for example, energy time or Euclidean space to frequency space, XYZ to K space. So many times it solves the mathematical complexities for us. Sometimes equations become easier, and sometimes, for example, in electronics and various other applications, we want to find the particular frequency composition, spectral decomposition of a waveform. So there also we do the Fourier transform and we see what particular contribution is coming from what particular frequency.
Okay, good. Have you studied the matrices?
Yes, sir.
Can you please tell me about the algebraic multiplicity and geometric multiplicity?
No, sir, I don't know. I haven't come across it.
I am giving you a hint, maybe you can remember. It is basically related with the eigenvalues and eigenvectors, if you remember.
Sir, like I haven't heard this term only.
You haven't heard this?
Term, geometric multiplicity.
Okay, cool. Okay, in the mathematical physics, have you studied some special function?
Yes, sir.
What is that? What are that? Please tell me.
So there are some differential equations which we can't many a times solve analytically. So we use various methods to solve them. Sometimes one of them is power series. We write the solutions in terms of power series, and then we apply the equation onto it, and by the recurrence relations, we find particular solutions to them. So there are various equations that fall into this class. The famous examples would be Hermite equation, Legendre equation, Legendre, Euler equation.
Okay, so among these, let's consider Hermite and Legendre. So can you please tell this mathematical special function, differential equation, which you tell, in our physics, how can we use that? Can you tell me any system or something where we can use this special function directly?
Yes, sir. So Hermite equations are very vital in solving harmonic oscillator in quantum mechanics.
Okay.
And also Legendre equations are useful in solving in spherical coordinate Schrodinger wave equation. So we separate the angular part, and that comes out to be Legendre equation. And
one significance for the Legendre.
I've come across it, but I can't recall.
It's a very famous system of the quantum mechanics.
Yeah, there's one. It comes in one system, but I am thinking.
Have you ever derived the expression for hydrogen atom?
Yes, there it comes.
Because many students, what he does, they directly remember the radial wave function. They never go through all the stuff.
The complete solution.
They will know that the basic requirement for deriving, okay, hydrogen atom wave function, you can say. Okay. So, question. My next question is from hydrogen.
Yes, sir.
Can you please wave function for the ground?
So can you repeat?
Is it disturbing function?
Hold on, sir. Yes, sir.
Can you please draw the radial wave function plot for the ground state of hydrogen atom?
Okay, sir. Sir, I'm not very sure, but I think it was something like this.
Yes, please mention the label axis. What are the
So
axis?
psi on y-axis and x on the. Okay, so
Psi
R, basically R.
What? What does it mean?
Psi of R, and so this is the radial part, not the entire wave function.
Right? It's for ground state, right?
Sorry?
It is for ground state.
Yes, sir.
Okay, fine. One last question. Have you studied about the waveguide in electromagnetic theory? Waveguide.
Yes, sir. But I'm not sure about it.
Okay, so if you remember, can you give me, can you tell me about the group velocity of the waveguide? How it depend upon the cutoff frequency and applied frequencies? Can you please, can you write that expression for me?
Yes, sir. So,
Okay, that's it from my side. Yes, sir.
Yes. So I think we should we have taken, all the students have performed well, I think, according to me. Yeah. All have given a good interview. So just keep preparing. You will be informed about our next round of interview, okay, soon. So you can join, you can come there. Okay, there will be many more faculty be present here for your interview. Okay. So all the best. All the best.
Thank you, sir.
sir, sir, I
Yes.
want to know about some feedback about the interview.
क्या चीज कौन? Who is speaking? Sonal.
Yes, sir.
हाँ.
Sir, I
About what?
want the feedback.
Yes, you're performing well. Okay. Yes,
Sir,
you have to
I-
just, your communication is good. Okay. You're replying confidently. Whatever you know, you are telling correctly. Or if you don't know, you're saying you don't know. Okay. So that is good thing. Now just you need to revise more.
Yes,
Okay.
sir.
So basically,
you know the basic main means topic of our physics syllabus, whatever it is. But I guess there is some problem if interviewer can ask from very interior part, like I ask you algebraic multiplicity and geometric multiplicity, you said you haven't heard about that. So
Yes, sir.
go through all the very small aspect, okay, which you think this is not important. How can they ask about this? Go through that topic, especially.
Okay.
फंडामेंटल जाने चाहिए सारे. जैसे अभी मैंने पूछा इलेक्ट्रॉनिक्स का फंडामेंटल्स यू शुड नो. ओके. रेजिस्टिविटी वर्सेस टेम्परेचर ग्राफ.
Electronics and solid state, I'm not very, like, I'm not doing it.
So basically
The interviewer will always ask from the basic. They didn't ask from very higher or advanced topic. They always ask the basic.
So I was expecting that I would be asked for some specific subject, so I thought I would go for classical mechanics.
No issue. Okay. That you can come for next interview also. Okay. There you'll see find more questions.
It is not necessary that interviewer will give you a chance to ask you your specific subject.
Yes,
it is up to him. Okay, it is up to them whether they can ask or they can't be asked. Okay, so not a mentioned rule anywhere, so they can come anywhere. Okay, all the best.
So basically interference, diffraction, ये जो basic चीजें हैं that you have to prepare. All the topics, at least basics you should know. Conductor to aeration, metal का conductivity कैसे vary करता है, semiconductor का conductivity temperature से कैसे vary करता है, thermal conductivity का definition क्या है, specifically temperature के साथ पे कैसे vary करता है. Okay, what is unit cell, what is Brevis lattice, okay, what is neutron diffraction, what is extra diffraction, superconductivity, MH curve. So that basics you should know. That will not take much time. Okay, if you go through each topic basics, you can prepare very quickly. Okay, the basics you should know. Okay, all the best.
Thank you, sir.
सर अभी तक मेरे को कोई मेल नहीं आया इंटरव्यू को के लिए करके.
कौन बोल रहा है?
सर हम पुष्पराज बोल रहे हैं।
तो अभी कहाँ अप्लाई किया तुमने?
हम दो जगह ICTS और NCBS में मेरा हुआ है। बायोफिजिक्स को हम लिए थे, बायोफिजिक्स ऑप्ट किए थे तो बेंगलोर। सर आवाज, सर आप म्यूट है।
रैंक कितना है तुम्हारा?
रैंक पता नहीं
रैंक
सर, वो नहीं दे सर, वो मेल आया था कि मेल के थ्रू हम वहां से NCBS वाला ऑप्ट किया था, वो नहीं चेक किए हैं।
तो कौन सा एग्जाम
रैंक सर
कौन सा एग्जाम क्वालिफाई किया है?
TIFR GS
अच्छा 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 अच्छा
23 वाला।
अच्छा। और ये गेट वगैरह भी अप्लाई किया है इसके थ्रू भी?
नहीं, गेट के थ्रू सर हम नहीं डाले हैं।
अच्छा
सर
अच्छा
उसी के थ्रू हो चुका है मेरा, तो हम वो नहीं अप्लाई किया।
अच्छा, वेरी गुड। तो अभी अभी इंटरव्यू कॉल आया नहीं है?
नहीं सर, अभी तक कोई मैसेज नहीं आया है।
हाँ,
Pushpraj,
तो अपने फ्रेंड से पूछो। हाँ हाँ, बाकी
TIFR always convey through your mails, okay? So just continuously check your mail. If they will call you, they will send you a mail. Simple.
ओके।
हम इधर से मेल करें या फिर छोड़ दें?
Yes, you can mail them, but I guess if you are shortlisted, they will mail you itself.
Just wait
Sooner,
for that.
mail.
Your
Sooner
mail.
later, mail if you are
और
selected.
एक जगह सर एक बहुत बड़ी प्रॉब्लम आ रही है सर, जब हम TIFR का जो वो एप्लीकेशन फॉर्म होता है वहां पर हम इनपुट किए थे तो 2000 लिखा था, 2023 में आपने TIFR के लिए इंटरव्यू कॉल किया था तो यस ऑप्ट किए। और जब हम वही मेल को वापस अभी खोल रहे हैं तो लिखा रहा है कि 23 को 20 बना दिया, फिर दूसरा जगह खोलते हैं तो वो 21 बन गया। ये सॉफ्टवेयर इसको लगता है उसके यहाँ से है।
Sorry, I can't tell about this stuff.
और कंफ्यूजन क्रिएट।
तुम अपने फ्रेंड के टच में रहो जिनका कॉल आया है, ओके? उनसे
नहीं
पूछो।
सर, इस बायोफिजिक्स में सर मेरे सर्किल में कोई नहीं है सर।
अच्छा, ठीक है। तो मैं पता करता हूँ यहाँ पर किसी का आया है बायोफिजिक्स में, ठीक है?
यस सर,
बताता हूँ।
थैंक यू सर।
ठीक।